This conference will now be recorded.
Okay, great. So today we will be talking about the neural network. And how does funneling process? Yes, ma'am, that's right. Funneling process. You're absolutely right about that. So let's talk about the introduction to neural network. Let's try to understand that why do we have neural network? What is the need for it? How does that work? How does they work? All that stuff. Let's discuss that. So the reason why we thought of developing the neural network is just because of one goal, that we wanted to know about our brain. We want to know the functionality or the function or the structure of our brain, how things work in our brain basically. So this is just a diagram that I've shown here. So the need for it was to understand the brain, and that is why we had, to understand how, our brain work, how our brain process when you see things, our neurons at a microscopic level, to understand it better. So that was the need for the neural network that we thought of. The reason why we also need a neural network, because we had good computing power, but we could not, at that point of time, with just by writing some for loop and just by writing some program, we were unable to identify between dog and cat. So you might think it's a very simple task, why the computer is not able to do that. But that's what we try to figure it out with the help of neural network. And let's try to understand why it's not possible with the help, without the neural network. So we thought that we have, according to the Moore's law, we had a lot of a lot of transistors and a lot of computing power, but still, with the help of a lot of computing, why we are not able to perform this simple task? Every time, if in computing, if we want to perform a task, we have to write lots of for loop, if else statements, right? I guess, yeah, we all love for loop, if else statement, but to sit and to write down all those instructions. If this happens, do this. If this happens, do that. In this case 3, inject disk. In case 4, dispense coin. So all these loops a programmer have to sit and write down. So we thought of, how does our brain work? How does we make decisions in our life? We'll try to understand the neurons in our brain. How does they work? How does our brain process information? How does it keep track of information? So basically, if we talk about the microscopic level, if you will look in the microscope in your brain, then you will have these different kind of neurons in your brain. You might have seen this sort of videos on YouTube, on in some movies as well, when they talk about the neurons in the brain and all. So basically, this is the core structure of a neuron. Is this is the in this is the this is some, you can say, some sort of root, and this is another route, and this is, you can say, this is a median wherein the information is passed on. So information is passed on, if we get some input, it will pass on that information to the output. Just like, you might be thinking it's just like an electrical circuit, but yeah, it does basically, it does pass on the information in the form of electrical and chemical signals whenever it receives some inputs. And if the input meets the threshold value, then it will what we call fire up. We call that firing of the neuron. Or if we receive some input and it is below the threshold value, then it will not fire up. Fire up, what I mean by fire up, let's say if you will press the button of your light, then it will get, either it will get turned on, or either it will not. So there are only two options that will happen. So let's try to look at the depth. So basically we call them dendroids, and this is the input. This is the input when we process information. The information is processed through the dendroid, and this is the cell body where the information goes, and it checks whether it is crossing the threshold value or whether it is below the threshold value. And again, if it is above the threshold value, then it will pass on that information to the axon, and the axons will fire up. just like switching, light switch. So this is cell body. I've talked about this. Now let's look at it this way. Let's look at a simple example. Let's, with the help of this flowchart that we have. So what we are saying, we have some input, and that input is going somewhere in the middle, which is in the previous case we can say this is a cell body where the input is going, and there is some processing happening where it is calculating something, and then it is giving out that information further. So now let's say at this particular point we have three inputs. We have input is coming from 3 points, at this point, at this point, at this point, and then it is going at this point. And now you might be seeing this this arrow is of bigger size, you know, it's highlighted, it's of smaller size, it's a very small size. So what we can say, this is the strength. We can consider it, it is a strength with which the input is coming. So let's say it is this neuron. So as I said, either the neuron is going to fire or either it doesn't. So let's say this neuron fire, and this gives information, sub information, which is a very strong information. It passes on that information to the middle layer, or this one, this blue one that we have here. And then this one gives information which is you know, which is also a information. It fires up with some weight, I will say, and this doesn't give any information. Now whether this information is going to go forward or not, it is going to depend on this neuron, this particular neuron. Now it is going to check the weights, let's say the information, let's not go to weights, let's say the information that it has received from the input layers, or from the input, I would say from the input neurons. If it crosses the threshold value, then it will pass on that information further. And how it is going to pass on that information, it might, you know, it is up to this neuron. It might pass this information to this one and this one, and it doesn't pass this information to this one, and it passed this a smaller amount, very little amount of information to this one. So this is how it works. It does pass the information, but it depends on itself, you know, this one, at the middle, that how much information it want to pass on to which output layer. So over here we can see through the diagram, it's passing very less amount of information. So then we come up with the idea. This was the first idea that came for the first neural network in 1943, which Warren McClough and Walter Pitts thought of. So they developed a neural network, the first computational model of neural network, with the help of this particular idea that they have in their mind. But then, you know, we've talked about, yes, this is how the neuron work, but we did not understand, or we didn't talk about how did the learning happens. How did actually the neurons come to know or make decision? How did they learn something? So let's look into that. So then what happens is that there was a Canadian physiologist. His name was Donald Hebb, and he come up with a research paper in 1943. And what did he said? He said every time a neuron pass in some information, it increases, you know, its weight. It learns something. It learns something, and that was, and it next time when it is doing the same information, you know, it makes in a it does that it does that process with some better accuracy. So what do I mean by that? I mean to say that if a neuron sees some task, or sees some information, and it fires up at the first place, right? It fires up at the first place. The second time when it is going to see the same information, it is going to fire up at a higher intensity. So that is what Dr. Donald have introduced to this concept, the firing up of the, and about the information. How does the information process? So let's try to understand this in a simple term. How does it works with us? Let's say you are trying to learn new language. Let's say you are trying to learn Japanese. So whenever somebody says Japanese, there are some neurons in your mind which fire up. So whenever, you know, you try to speak that language, and it fires up again and again. So when you do more practice of the Japanese language, and so that these neurons gets fired up every time, and it gives you the retention. It stores the information in your brain, and that's how you get perfect in language, and any language or anything. That's what we say, that we say that practice makes a man perfect. But what is the logic behind it? We say that if we'll practice maths question, if we'll practice English, we get better. But what is the reason behind that? So this is the reason. The weightage, you can say, or the tendency of a brain, it gets better every time whenever we do the same task again and again. That's how we call nowadays. We feel like, whenever I'm doing something, there are a few things that you do, you might feel very excited about them when you are doing them. Maybe it might be, for someone it could be singing, and you want to do it more. You do that again, you do that with some better accuracy, and you feel good while doing that. So this is the concept that Dr. Donald have introduced us with. Now this was explained up here, that if it gets it is the if the dendron receives some information, it does some task, and again it does the same task, it will do the same task with a better accuracy, because now that it has understand how to do that particular task. And that's what we call weight, because it is going to assign some weights to that particular task. By weight, what I mean by that is that whenever you are doing a task, or whenever you are learning English, every time you speak, not English, let's say Japanese, that example that we were going for, you were learning Japanese. The first time when you spoke Japanese, you felt, what is this language? I mean, but after some time, when you keep on practicing, you keep learning something better. So the language quotient keep on increasing. So we'll say that that is the weight. The weightage for that particular language in your brain has increased. You are start giving more importance to that particular language, that yes, this is something that I want to do more. You can relate this to some of your hobbies. Some of you might follow some hobbies, maybe going to gym, maybe doing some sort of exercise, or practicing yoga, singing. People have different sort of hobbies. So whenever they do that task, they assign the weight to that particular task. How does that work? Let's say you come up with, let's say somebody asks you to read the history literature, and you feel very bored reading that history literature. You go and try, you just because somebody said it, you just go and try that out. And when you go and try to read that literature, you feel very boring, so you won't go and do the same task again. You won't give the importance to that particular task. Let's say you like maybe some sort of horror stories, or some sort of sci-fi books or sci-fi movies. So if you watch that particular movie, or maybe if you read that particular book first time, if you feel excited reading it the first time, then you will assign that some weight in your mind, that yes, this is important for me. I feel very good when I do that particular task. I should do it more. And every time you do it more, you get better. Well, it depends on the task, what task you're doing. If I talk about movies, how can you get better watching movies? But if you are doing something something good, which is productive, maybe learning some new hobbies, maybe practicing something, maybe coding, or maybe it could be anything which could add some value in your life. So every time you do it, you gets better, and you assign weights to that, and the weights get updated every time you do it. So that's how the neural network works. Basically, the first time they will do the task, they will assign some random weights to it. The next time they do it, they will again update the weights, whether they perform the task in which fashion, whether they liked it, whether they didn't like it, whether they are able to do it in a good way or not in a good way. So does that mean now do we understand our brain completely? Well, I want to say that we did, but actually we didn't. I mean, we couldn't. We are on the way to learning more about our brain, but these are few concepts that we picked out from our brain. That this is how our brain works. This is how some of the tasks that our brain do. So did you understand it? So we can proceed further. And this is how, okay, great. So I wanted to keep it slow today because so that you can grasp what I'm trying to tell you, and you can assign, you know, good amount of weights to the learning that I'm trying to provide you guys. So I want you to assign good weights to the learning that you have, and so that you can practice it more. So this is how we do image recognition. If we are able to assign weights, then we'll be able to do the image recognition. When we see someone, we'll assign some weights, we'll remember some of their gestures, and next time when we see them, then yes, we recognize them with the help of some weights. Now let's talk about what is layers, what is features, and how the learning actually happen in the neural networks. Okay. Now, when you go on the internet, or maybe on the hacker rank, or maybe on the LinkedIn, on most of the time on the Google, it's trending news about the deep learning. It's the advanced topic. Everybody wanted to learn it. You know, you can do a lot of things with it, but let's see, you know. And we have also seen AlphaGo, you know, beat the Leo pseudo, the, you know, the winner of the game, particular game. You might have heard of this, right? So this can only be achieved with the help of deep learning. We also might have heard of the car, you know, self-driving car, which is Google working on, and which is also Tesla has already developed. So they are, how they are able to do that particular task, how the car know that this is the point that it has to stop, that this is this, because if you will write a code, if you will write a code for designing a self-driving car, so you can give some instruction. Let's say if you see a red light, then you might say it to stop. So your car might be going at a speed of maybe 120. When he sees the red light, it is going to take the speed from 120 to 0, but that is not good for you and not good for the car. So these sort of decisions, you know, the deep learning models, they make it, you know, they make better, they make mistakes, they learn from their mistakes, and they make them better. The learning curve is again same. When the learning curve that we have seen at the first place, it is going to make some prediction, then it is going to find out the error, and then it is going to do the evaluation, and it is going to go back, and it is going to make the same, you know, some different mistake and learn from its mistake. And in that process, it is going to assign different weights to that. Now this is one of the application, you know, that we have, Google Translator, which also sings. Let's see what I mean by that. Okay, so we also have a song for that. Let's go with that. Hang on. Yeah, so this is how deep learning is different. You know, you might be thinking that how it is different from all the algorithm that we have, like linear regression, logistic regression, decision tree, and this is why it is different. We'll look into that, how it is more different from the other fish that we have in the pond. Let's see. So far what we have understood, what we have seen is that's called shallow learning. So what do you mean by shallow learning? In shallow learning, you have to select the features on its own, and you have to do the manipulation on those features, which feature is important for you, how you are going to assign the weights to that particular feature, and you try to find out these values, the alpha 0 or alpha 1, you know, the theta 0, theta 1, and so on and so forth. But when we talk about, and then what we try to do, maybe we have this sort of data points. So with machine learning, what we try to do, we try to plot a linear line on them with writing some of our own code, and it will plot the linear line on them. Maybe we have this sort of data, which is not a linear function. So we could have some sort of curve for tracking the value of that particular data. This is a relationship between the distance from employment and to the pollution. This is Houston house price data, so it's about that. And might be you might have some case in which you have different points and you want to divide those points. So if you want to divide them, you cannot divide them just by drawing a linear line or just by drawing, some logistic curve. So you might have to draw this sort of curve. But how you would do that with your algorithm? You might have to do different sort of transformation on your algorithm, different sort of feature selection on your features that you have, which feature you should select, how you should manipulate the value of that particular feature that you have. I know we haven't talked about it, but this is what we do in machine learning, right? And but when we talk about deep learning, in deep learning, you don't have to take all these headaches. You don't have to worry about selecting the feature. You don't have to, think about the feature selection, the feature extraction. You don't have to worry about manipulating the feature, which feature is important for me, which is not, what is going to be the value of theta 1 and theta naught, all that stuff. That is the thing that you don't have to worry in case of deep learning. So let's look at how this deep learning works basically, and where do we use it. So where we use it, let's say we have a training data, and we have some pictures of cat and we had some pictures of dog. So what we want to build a model. So we want to build a model in such a way that when we fed the data for the cat and when we fed the data for the dog, our model can detect that whether the data that we have fed, is it the image that we have fed, is it the image for the cat or is it the image for the dog, or not cat, I would say. Now how does that happen? So basically we have some training data. We will give a model different training images, like we do in case of machine learning. We give different data points to our algorithm and it does some manipulation on those algorithm. It finds its different value and then it gives us output. The same thing is going to happen with deep learning. We are going to fed the testing data and then we are going to send that data to a model, and then based on some algorithm that it will apply, based upon that we'll have some output. Either it will tell is it a cat or not. So in this case, yes, it would be a cat. Now what is training data basically? So for training data we need high resolution of images, different types of images, right? I think I've talked about this at the first day when we were learning, when I give you the analogy of tomato, that when we were kids and we were learning about different tomatoes, so we showed them different pictures to kids, different pictures of tomatoes of different colors or different size. So we do with the cats also. We show a model different pictures of cats, of different color or different textures, as you can see, and we tell the model that label data, we call it, in machine learning we call that to be supervised learning, but in deep learning we call it to be labeled data, because we have to tell the machine that this data that I'm providing you, this data is for the cat and this data is not for the cat. This data is for the cat and this data is not for the cat. Right? I have to give some labeling at the initial stage for the machine, for the machine learning, or for the deep learning model to make any decisions. So but what does it do basically? So it takes away the power from us. Basically we are not really doing anything for now. We're not doing any programming at this particular time. We are not extracting feature, we are not doing any manipulation with the feature. So that is basically we given the task to the computer to do some manipulation on our work, and that is basically the data science is, or artificial intelligence work. Basically we are giving the power to the computer, we are feeding the data, which is a labeled data, to a model, and let it decide that which one is coming into which class and which one is not coming into the other class. So we just have to sit and wait a model to complete the training. So let's look at this way. Let's say how basically the learning is going to happen. So let's say we have our data, the training data that I've talked about. Yeah, there were some images that I was talking about. Yeah, these images that I've talked about. Let's say I fed the training data to my model, and based upon this training data, what my model did, it decided to have 6 input layer. Or let's say our model has 6 input layer. So what does 6 input layer means? That means at one time it is going to process 6 different type of information from the same data. From the same data, it is going to process 6 type of input. It is going to receive 6 type of input from that particular data, and then it is going to try all the permutation combination, send this information to the middle layer, and this middle layer, we call this layer to be the hidden layer. And then based upon the input that it receives, it will make some decision and send that information to the output layer. So do you follow what I'm trying to tell you? This is the fully connected network. One input is connected to 6 output at this point. You can see to this, to this, to this, to this, to this, to this. So it is going to send the information to this as well, to this as well, to this as well. And it is also going to, this model is going to basically receive the information from 6 input, just like this did. Now the reason, we'll talk about how it is different from, how this layer is different from this layer in the next slide. So let's say that it receives some information, and then it's based upon some feature extraction, it extracts some feature and it sends those feature to the hidden layer. Now the hidden layer, based upon the weightage average, it will send the output, it will send that information to the output layer. Now how the output layer is going to work? Now the output layer is going to work in this way. There was a step function that we have at the first place, but nowadays we are using this probabilistic function basically. So what does it mean basically? Let's try to understand. Let's say we have 6 hidden inputs, and our 6 hidden inputs giving me the output. Let's say that my input is my 4 inputs are saying that the information that you gave me, based upon that information, I can say, this one is saying, I can say this is a cat. The image that you gave me, it's an image of a cat. This one also say that this is a cat. This one says nothing, because I said either the neuron is going to fire or it doesn't fire. It's going to say nothing. Then it will say it is a cat. Then it is going to say nothing. Then it is going to say it is a cat. Now we have 4 yes and we have 2 no. Now this model is going to decide based on the weighted average, and it is going to take the probability, that what is the probability of the input image that I have, that of it to being a cat. So we'll say it is 4 by 6, which is a very high percentage, and we'll set some value that if let's say for now, let's say if it is above 50% or above 0.05, then we'll put in this category. If it is below 50% or 0.05, we'll put it in this category. So in this case we have it above 50%, so we'll say yes, this is a cat. So this is how the learning works, and this is how different layers in this neural network works basically. So this function that I have here, which is going to make a decision, this function, the probabilistic function that I have, is called the activation function. Okay, this is again a new jargon that we have, but I guess we have to go with it. This is a new jargon that we got, that is activation function. Some of you might have read about, these activation functions. We have different type of activation functions, ReLU, sigmoid, right? I guess some of you might have read about this. Any of you have heard about these functions, activation functions? Sigmoid. Okay. So yeah, it's a probabilistic function, sigmoid. It's a multi-layer perceptron. Yes, yes, yes. Yes, sir. We'll talk about that. Yes, yes, yes. Right. So when I was talking about, this is the input layer that we have, and this is the hidden layer that we have. And as Sir pointed out, this is a multi-layer perceptron. I don't want to give you this name because this is again going to bounce off. So let's say this is a simple neural network that we have, and after having some information processed to the hidden layer send the information to the output, and based upon the input from the hidden layer, the output layer makes some decision based on a function which we call a activation function. Okay, so this is how the learning take place. Basically, the inputs get connected to all the layer and it assigns some weights to that. It assigns some weights to that at the first place. It gives some random weights to it, that I give this much weightage to this, I give this much weightage to 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 this. It does the same thing, it does the same thing. Then it makes a decision. Then based on the decision it is going to make, then the weights are going to update it in this fashion. First these weights are going to update it, then these weights, then these weights, and so on. So let's try to understand what I mean by that, how the information is basically fed. Now we have seen the this is basically the 3-layer, and this is a 4-layered information. Now how this is affecting our model, how this is giving us better accuracy, let's try to understand that what is the difference between having one input layer, one hidden layer, and one output layer, then having one input layer and 2 hidden layer, and then making a decision, right? Because the reason or the advantage that I would say is going to be, when I'm going to have one input layer and one hidden layer, what is going to happen in that case? Let's look at this way. So it is going to process some information, it is going to do its feature extraction, and based upon those feature extraction, it is going, this hidden layer going to give some decision, going to make some decision. It will create its own feature, and then it will give that information to the output. Exactly, we'll get more accuracy. But in case of when we have 2 hidden layer, what will happen? It will fed the when we'll have the input, and it will give us some information related to the feature. Then this hidden layer will create its feature, and it will pass on those feature to another layer, maybe this hidden layer that we have. And this hidden layer then creates its own features, right? I'm talking about the features again. I'll give you an analogy that might give you the understanding. I have that in the next slides. So this is going to create its own feature, and it is going to send those based upon those features, it is going to make a decision, and it's going to send that decision to the output layer. That based upon the feature extraction that the first input layer did, based upon the feature extraction the second hidden layer did, and then what I've understood is this is going to be a cat, this is not going to be a cat, this is going to be a cat, this is going to be a cat, this is going to be a cat, and then the output decides. Now let's stick to this for now at least. So how does the input layer work basically? How does we decide how many input layers we should have? How many, I have here mentioned 6 inputs, right? So how should we decide that how many inputs neurons should be there? Let's look at this way. Let's look at how the data is going to fed into a model. Let's look at this way. So I've also given another example in case when we have 3 hidden layer basically, then it is again going to give us more accuracy. This is going to give some features, this is going to create its own feature, pass on to them to the second hidden layer. The second hidden layer going to create its own feature, then it is going to pass those feature to the third hidden layer, then the third hidden layer is going to create its own feature, and that information is going to be processed to the output, and based upon all these hidden layers and inputs, then the output will make the decision. So you can clearly see there will be more accuracy. Now when you are solving one question, let's say you are in a class and you are solving, you are in a high school, so your teacher gave you one question to solve, so you solve that question and you ask your friend whether I solved it correctly or not, and then your friend did some manipulation, yeah, this was a mistake, you could do it better. then the other friend pass this question to your another friend, maybe sitting on the next bench or somewhere. So that girl or that guy or boy or girl solve that question and tell this was the mistake that both of you were making, we could do it better. Then it will pass to the another guy in the class, and then that guy is going to solve that particular question. Might be it finds some mistakes in that particular question, it will solve that question. Then we are going to make sure, before showing it to the teacher, what we want to do, we want to pass this information to the smartest guy in the class. So let's say this is the smartest guy in the class. All the equations that we have applied, the way we solve it, we send it to that guy, and he'll see all the the improvement that you did in the question. Then he'll, based upon that, he'll say that yes, this is right and this is not right. You could do it better. Go back, because that's, it happens all the time. The smartest guy, he's not going to tell you the answer. He'll just say there is a mistake in your question. You can go back, you can solve it again. Then you might go back, you might try to solve it again, and then the same process follows. So I guess this analogy gives you some understanding of it. Now let's see hidden layer, hidden layer. Sorry, accuracy of network by increasing hidden layer. Neuron in hidden layer is not. What is that you're trying to point out? Accuracy of network by increasing hidden layer. Neuron in the hidden layer is not correct. Yes, it is not. I'm just giving the basic idea for now, at least. Let's not talk about specific things, because everybody won't be able to relate this, right? Because they don't know about for now the hidden layer, what is the purpose and all. So let's just stick to basics for now, at least. Now how the data is going to fed into the model. Let's look at that. Let's say I have an image of cat which is just like this. So the image is 30 cross 30. So you might be all aware of this fact that image, we have some pixels related to those image. So let's say this size is 30, this size is 30. So 30 multiplied 30, that is 900. So it will have some values for it, and this is going to be in this form of matrix. We're going to convert that in this form of matrix. You can call it, just call it array, whatever you like for now. So it will have some value. So what are these values basically? So these values are for different colors. It might have, it has different colors at this particular point. It will have different values for that. It has different colors at that particular point. It has different values for that, and so on and so forth. So we have approximately around 259 pixels, somewhere around that. So we will have this different combination of numbers in our in our matrix, and this is the number of input that we need to create, right? This is how the data is going to fed into the system, and a model is going to look at each number. Now let's look at one example, another analogy I will try to give you, and maybe then you can understand this, what I'm trying to say. So let's say I give this image, which is an image of giraffe, and I convert that image into this form, and I fed that image to my model. Let's say this is my model for now. Let's go. So what happens is that when this information is fed into the first input layer, the input layer will send that information, and it might extract some information from it and send that information to the hidden layer. So that some information could be the edges. It could extract, it could have identified that this image have these edges, this image have these lines, or maybe this color is different at this particular point. So that information is processed to this particular hidden layer. Now let's say for our understanding for now, that this hidden layer, what it does basically, it creates its own feature. Because what happens is that when you tell some things, they have their own understanding towards it, right? When you tell a story to a person, it will create its own analogies, it will create its own understanding, or it will create own perspective to that, because subjective point of view it will take that way. So it will create its own feature. So maybe based upon the input that it had received, now it is able to identify the texture in the image. that what is the texture in the image, what is the specific color that this image has, maybe which part it has more contrast, or different thing it can do. Now it passes that information to the another hidden layer. Now what this hidden layer might do, this hidden layer might do give it more precision. It identify the textures, so it might identify some dark spots in the image, maybe some whiteness in the image. It could be of different features. Then it will create its own feature. We don't know what those features is going to be. Let's say it identify the whiteness in the image. Then after seeing all the output of this hidden layer will create its own feature. Let's say for an analogy, let's say that it creates maybe the eyes, it creates maybe the nose, it creates maybe maybe the face, it creates might be the leg of that particular image that is fed. Then it sends that information to this output layer. For our understanding, let's say this is the CEO of the company, and some information was passed into it, and it got passed on to, let's say, to Mark. Now what happens is that Mark is talking to his senior managers. So Mark is asking, you have done your analysis, right? So they said, yes, we did it, sir. So tell me, based upon your analysis, what exactly you conclude. Do you think the image that we have, is it an image for cat or not? So this guy at the top, he says, yes, sir, according to me it is a cat. And this guy say, yes, sir, because he follows this guy, and he say, yes, sir, according to me it is a cat. This guy say, yes, I also believe that this is a cat. And this guy says nothing. He says, you don't want to say anything? But we'll not ask this question, because we have talked about this. Either this neuron fires or it doesn't fires. So he doesn't say anything. He just says silent. He just says, sir, I need more time, I cannot decide for now. Let's say he say this. So Mark look at all its output, sorry, inputs that he have received, and then he'll take the weighted average. Weighted average, everybody is familiar with that, I guess. So he'll say which answer has more weightage, which answers has more weightage, and based upon that he find out that 3 of his managers are saying that it is a cat, so he should listen to them. This guy, he's saying he needs more time. I mean, what exactly he did, I gave him a lot of time to do the work. Why couldn't he complete the work? He couldn't give me an answer. So I'll stick to these guys, and I'll say that yes, I'll give the client to the answer that the input or the image that you gave me, it's of a cat. But we know the answer, right? We know that this is not a cat. So the client will tell him, Mark, what exactly you did? That was not a cat. What exactly are you doing? You take so much of time of ours, precious time, and you are not even telling me the right answer. So the client will yell at Mark, and Mark will go back and call up all his manager for the meeting. So they are sitting at their fancy chairs, maybe a $45,000. They're sitting at their chairs, and Mark asks them, tell me that how did you decided? Or he doesn't ask this question. He says, because this is what happened. This doesn't happen, He's going to come. He's going to start yelling at them. He'll say that how can you say that this is a cat, all that stuff, the bossy stuff that we hear, that how can you decide, blah blah blah, and all that stuff. So this manager, what is going to now, the perception that he will have in mind, that he need to listen more. He didn't listen to this guy, he need to take better decision. So what he will do, he will give some weightage to these layers. Now he had some weightage for this, he gave more preference to this guy. Then he thought, yes, this is also good, this is also good, and he thought this is useless. So now he updated his weightage, or he updated his idea regarding these managers. He said, this is not good, this is not good, I'll reduce its weightage. I was giving more weightage to this guy, is what he was saying. I'll reduce the weightage of this, I reduce this weightage of this guy, and also maybe I should give importance to this guy, because he didn't give me the wrong answer. He didn't give me the answer, but he didn't give me the wrong answer, and that is very important. Not replying is good, but giving a wrong answer, it's very bad. It's not good at all. So now they are angry. The managers, they are angry because Mark yelled at them. Now they are very angry. What they gonna do? They're gonna go back and they're gonna call up another meeting of their associates. So they're gonna ask their, or maybe the sub managers or the manager or the leads, whatever you can call them. So they call the leads and they tell them what exactly you did. Mark told us so many things. Just because of you, we have to hear so many things of Mark. He yelled at us. He did this. He's going to fire us. All that stuff. So they'll say, so we'll look into it. We'll look into it. And now this guy also going to decide, maybe I listen to this guy too much. I need to reduce it. Reduce to this guy also, reduce to this guy also, and so on and so forth. So they also updated their weights or importance that they were giving to these guys or these associates or leads. Now what happens is that because they have received information from somewhere else, now what they're gonna do, they're gonna go back and shout at their associates, or maybe, yeah, let's call them associates for now. So they're gonna go and call up another meeting of the associate and they're gonna yell at them that why you did what you did, all the same, blah 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 stuff and all. So then they are also going to, after the end of the meeting, they'll say, yes, we'll go back and we'll do the work again, right? Now once the meeting is over, they are also going to update the weights of the inputs that they were receiving. Maybe they were giving more importance to this one, maybe they were not giving importance to this guy, maybe not to this guy. So they will update, they will give importance to the people that they haven't listened before, and they might reduce the importance that they were giving to the people at the first place. Now these one, the associate that we hear, what they're gonna do, they're gonna go and they are going to shout or they are going to yell at the interns, because they have received this information from the interns. The interns got the data at the first place, they did the manipulation at the first place. So they're gonna go and yell at them and they're gonna tell them, go back and update your stuff and all that stuff. So what these associates they are going to do, they are also going to update the weights that they were giving to the interns basically. Now what should the intern do? They only gonna yell at the data, right? They are just some numbers. They're gonna yell at the numbers. Now then the next time when they will see these numbers, then they will try to look at them in a more careful fashion, or maybe more precisely look at more concrete things, and based upon that then they will have some conclusion. So this process of going back, updating the weights, and the mistake that you did at the first place and trying to correct that mistake, going back and updating the weights, this process is called back propagation. Again, a new jargon. So I guess we have to deal with this. So this is what the back propagation is basically, to update the weights in the reverse fashion. We are making some decision. First of all, what happens is that when we make some decision, we have already assigned some weights to these input layers or these hidden layers. But once we have our prediction, we compare that prediction to the actual value. And if there is an error, then we go back and try to correct our mistake. Just like we did with linear regression. First, what we did the prediction, then we made the error, then we tried to reduce the error in the second time, and then we repeated the same step. So this is how the working of neural network works basically. So this is how, now you might be thinking that how we are going to reduce the error. We are going to follow, we will have again some sort of function, the cost function or the loss function. We'll try to reduce the loss function, right? So just like we did yesterday with gradient descent, we try to reduce the gradient descent using the slope and the function, try to moving the learning curve, all the stuff that we have discussed yesterday. The same stuff is going to happen in the networks also, in the neural networks also. So basically, if I go back, this was just an analogy basically, but in real time what happens basically, we don't know what kind of feature this network is feeding to this particular network. What is the analysis, based on what analysis it found the maybe the color, based on what analysis this found the line, based on what analysis is found the texture in the image, and based on what analysis this found maybe the eyes, or maybe we don't even know whether this hidden layer found the eyes, or whether this found the eye, or whether this found the eye. We don't know that. So basically for us it's just like a black box, we can say that, because we don't know what exactly is happening inside the neural network. And understanding the neural network, it's again a different part of machine learning. We have different people who does this analysis for us. Their job is to, they are trying to understand how the actual working of neural network is happening, how the work is happening in the neural network, how we are getting some function, how we are trying to reduce that particular function, how we are creating the gradient descent, how we are trying to reduce the gradient descent, how we are updating the weights, how we are adding the bias, all that stuff. That's a different part of the study. So that's now what we have understand so far. We have understand that how the neural network makes a decision. The neural network makes a decision based on a function which we call activation function. How it makes a decision by updating its weight, and updating the weights is called back propagation. The process of going back and updating its weight, it's called the back propagation. Now this so far this is what we have covered. So did you understand what I tried to make you guys understand from this topic? Did you understand what I'm trying to tell you? Great, great. Any questions, any questions that you have, the basics questions, whatever I've explained? Do you have any questions related to that? Please tell me. So you might now might be able to relate by the analogies that I try to give you. Okay, so this was a lot. This was a lot that we covered in an hour. So let's do one thing. Let's take a break for 15 minutes. So then we'll talk about more about the disadvantages that we have with the neural network. Okay, so everybody can go. Sir, is it possible to implement through Python? We'll talk about that, ma'am. We'll talk about that in the coming slides. We'll talk about all those things. So there are disadvantages to it. We'll look at the disadvantages the next when we're going to back, and we're going to talk about the disadvantages, what we have and all that stuff. Okay guys, so let's take a break for 15 minutes, and you can have a cup of coffee or glass of water or whatever you like. Then we can proceed further. Okay.
So, Nandesh, what will you call it? Will you be calling it a remote tea or remote coffee session?
Whatever they like, sir, whatever they like. I mean, if they like coffee, then they can go for the coffee session. If they like tea, they can go
Remote
for the tea.
coffee. See,
Yes.
see, with 3D printer, now we can print biscuits, we can print pizza, and we
Right,
can print many things. We know even puris also with 3D printers. So
right,
can't we
right.
have some machine through which we can have remotely, we can print, or we can some liquid, we can have some e-flow of liquid or coffee.
Sure,
Machine
sure,
learning problem.
sure, sir. I have
On
faith. I have faith on all these participants. They will do it someday. I'm for sure for that. They will do it.
it was on it was on lighter side, but we know driving cars, driverless
Right,
cars to this. So this is also a possibility. Okay, so after 15 minutes, we again catching.
right, right, sir. Right. Okay. Thank you. 15 minutes break we have, and we'll start again at around 12:15 or 16. Okay, everybody. Sir, you are making hungry now. Okay. Okay, great. So we'll talk in next 15 minutes. Bye bye, guys.
Tawfiq, are you there? Hello,
Hello.
Tawfiq, are you there?
Sorry.
Tawfiq, is Tawfiq there? One of the participants?
Tawfiq. Let me check, sir. Tawfiq. Tawfiq is there, sir. He's muted.
Yeah, you can please ask him to get it unmuted. Maybe
Tawfiq,
he
if
can get it.
Tawfiq, can you hear us? Maybe he went for the coffee or something, sir.
Is he the same one who is from Oman?
Sir, I don't have an idea about that basically.
So you can ask him because he
Uh-huh.
is a professor. He's a senior faculty with the University of Oman.
Okay,
So
okay,
I would love to find out whether he is
okay,
the same fellow.
okay. Yeah, we'll ask him, sir. We'll ask him once.
Yeah,
Once he.
because when Tawfiq was my PhD student way back,
Okay,
and he did a lot of work,
okay,
especially on this intelligent web.
okay,
So that time around. So I'm pretty keen to inquire whether he's the same fellow.
okay. Yeah, we can surely ask him once he's back.
Nandesh, you will have an hours session after this
Uh,
break, an hours.
Sure, sir. We'll do that.
We'll just conclude and this, so then we can, if we have already received their, the feedbacks, if we have them,
Uh-huh.
so maybe we can find out whether we should have one more, because already one more lockdown has been announced by our honorable Prime Minister.
Yes,
So
sir.
maybe we can have more such session, more such program. So
Yes,
about this viability, whether we should have it or how to, because ultimately it will also be needing resources.
right, correct.
So we will just try to find out how will it
Correct.
go.
Sure, sir.
So on
Sure,
the
sir.
basis of responses.
Sure, sir. Sure, sir. Okay.
So how is
Thank
it
you.
in Delhi? Is it fine? Which locality are you in?
So I'm in Ludhiana. I'm in Ludhiana right now.
You are in Ludhiana. So
Yeah.
Ludhiana is all closed.
Sorry?
Okay. Ludhiana is all closed, locked down.
Yeah, yes, all India is locked down, sir, right now. I was
But
in Delhi.
there was some activity. Yeah, it was there was because traders and these manufacturers in Ludhiana, they were demanding, especially these bicycle walas, they were demanding that
Uh-huh.
this production must start because there are hundreds
Yes.
and thousands of workers, those
Right,
who are
sir.
working there. So they
Right,
are all in
right,
despair. They want this
right.
lockdown to be relaxed. And Punjab government, they came up with something. I don't know whether it has been implemented.
Yes, so
So I
what the
don't know.
government said is basically they said if they can keep the worker, if they can give them shelter, if they can give them food, and if they can take care of the worker, they can start the work. But then they said they
That was
yeah, they won't be able to do it.
uh, there was the catch. There was the catch. Few of them they have already done it,
Yes,
wherein they
yes, yes.
were needing a smaller set of workers and a smaller number of workers,
Right.
but wherein they have large number of workers to keep them,
Yes,
24
yes.
by 7 is difficult for them.
Like hero cycles we have in Ludhiana, we have even cycles, so so they are big companies that we have here. Might be, they have the meetings going on. Maybe one of my friend, he's working with Avon, so he said like they're gonna call him for the meeting of some sort. So they might be planning to do something.
Nandesh, how far is because this Ludhiana road, this Chandigarh, Ludhiana. So there is the
Hmm.
Chandigarh University, CU,
Yes.
and it's a private university, not this Punjab University, not that one,
No, no, yeah,
but this
yes.
Chandigarh University, because I was part of this UGC team that visited that university for the necessary, this regulatory part. And I
Okay,
was pretty surprised to see that university, lovely university, beautiful. And the kind of
right.
work, especially their robotics, this laboratories and all the facilities, especially in fact for all this also, data sciences, I
Right.
think excellent facilities.
Right,
So
right, sir, right.
yeah, and large number of students. They not only they were that time they were involved in so many different projects. So it was
Right, right,
about
right.
a year back, not even a year back.
Right.
So
Uh-huh.
about 8, 9 months back. So
So they have
it
like
is in Ludhiana, Punjab.
they have three campuses, in that particular region. It's in Mohali Road, I guess. Mohali Kharad Bypass Road, somewhere before Kharad, I guess.
I don't know, but the name of this university is the Chandigarh University, and this
Yes.
promoter owner is also known to me. And there was some Kapil Suri. He was also with
Okay.
this one. So I don't know, but I was
Okay.
pretty impressed. Though it's a private university, and but
Right, right, right.
excellent facilities. So
Right.
I was pretty. It is on this Chandigarh Ludhiana road precisely.
Yes, sir. Yes, yes, yes. It is on. It is like approximately it's like 70 to 80 kilometers away from Ludhiana.
Okay, okay. But
Yes.
lovely campus.
Yes, sir. Yes.
Chalo,
It,
so
have you
by
been?
the time, because
Mhm.
you were
Yeah, go on,
asking
please.
something, yeah.
I said, have you been to Chitkara University in Chandigarh? We have Chitkara University also. It's also very amazing. They are also doing very good work. It's also a private university.
No, no,
Chitkara.
Chitkara, I haven't been to, but
Okay.
Chittor University. I have been to
Chittor, yes.
Chittor, part of this
Okay, okay.
Chittor University. Chittor
We have
University,
heard a lot.
again, the
Yes, yes.
What about lovely
but this
Professor
Chandigarh
University?
University. Hello,
Somebody's asking what
somebody
about
was there.
A lovely Professional University, Punjab, Jalandhar.
Yeah, yeah, there is this lovely professional university. Again, lovely university.
Basically,
Naam is lovely university.
I'm doing PhD over there in computer applications.
Computer application. Who is your head of department and what's your good name?
My name is Gauhar Mohideen.
Okay, that's been fantastic. So where are you? Where are you in? I mean, you are in Chandigarh only at the moment. Where are you from?
I'm from Jammu and Kashmir and I am at home this time.
Where are you?
You're lucky.
Which location in Jammu and Kashmir?
Anantnag.
Oh, lovely, fantastic. So we have our participants from all around.
Yes,
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 sir.
good to.
Yes.
Good, good to find so many. I'm very happy. Good, good. But Jammu, see, in Jammu University, this is Vaishno Devi University.
Yes, yes, yes.
Do you know about it? So there is one student of mine. He's Gandhi, Naveen Gandhi. So he is
Okay.
with this computer science. Yes. So they are also running several programs and programs of consequence, good programs. So and
Right.
Jammu University and Kashmir University. What about Kashmir University? Is it
Yeah,
how is
I
this
have done
doing now?
masters from that. I have done masters from Kashmir University.
From Kashmir University.
After that, I
Okay,
was
okay,
working
okay.
on contract basis for 2, 3 years. And then I left that, and
Okay.
presently I'm in the second year of my
Acha,
PhD
presently
course.
pursuing.
Yes,
Okay.
yes,
So
yes.
what is your topic like? What is your topic like?
Prediction of Alzheimer disease.
What is this?
Prediction of Alzheimer. This is Alzheimer brain disease.
Okay, 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 okay. It's a good one. So which tool again? Soft computing you using?
That's why I am facing problem how to tackle these images. I have a 64 GB data set, and I am facing some problem. That's why I joined this course.
No, because ANNs, you see, ANN can be a pretty handy tool. And
No,
if I
what
no,
problem
if
I
I
am
could tell
facing?
you,
No, what
if I
problem I
could
am
tell
facing
you,
currently? What
yeah,
problem I am currently facing? Basically, I am in the first stage of my research, and I am facing problem how to tackle these images. Basically, my image data set is in the format of NIF, a Nifty format,
okay,
where I am
okay.
facing little bit of problem.
So have you
But
tried any?
I
Nandesh, I just want to ask him. I just want to ask you. Where did you get your data from?
Adani
Is
Adani
it
website.
classified or it is on public domain?
It's on public Adani Alzheimer disease neuroimaging initiative.
Acha,
That's open.
Alzheimer.
Yes, yes.
It is for Alzheimer one, because I had certain access to certain data sets, and especially from this PGI Chandigarh, and
Okay,
it was on yes, oncology, and one lady, some girl, she was doing that work and she had come to me. So
okay,
it was there, but it was not specified data set. So maybe I have that. I have a few research papers on that. And
okay,
actually, in the beginning, she had same set of queries and same set of problems. So, but somehow we could resolve. And almost on similar lines, people are conducting, a lot of research work at
okay.
this Vanastali Vidyapith University. So maybe we can have, we can again connect dots and we can have a research group. So,
Yes,
I
yes.
mean, advantage of such programs is we get to know each other and then we can start working on different research
Yeah.
problems also.
Basically, I want, if you don't mind, your contact number so that I can have a little bit of conversation with you people so that I may get somehow, how can I tackle this problem? Because I am in the
Don't you
first stage.
don't you worry. Who is your supervisor?
Dr. Ashok Sharma, he's from Jammu, associate professor.
Okay. So maybe we can have a some platform on which we can discuss these issues. But
Yes.
minded, the more you explore, more you research into it at
Yeah.
initial
But
stages,
these
the
days we
more
have a
wiser
problem
you
here.
are.
Basically, we have a problem here because we don't have 4G connectivity here right now in the Kashmir. We are stuck in the 2G, and I am unable to download any research paper right now because I'm using my
I
mobile phone right now. I was unable to connect it with my
know.
laptop.
That's a huge issue. That's a huge issue.
Very, very
But
big
rest
issue. I am
assured,
unable to download it
all
in
these
the
G's
file.
will be with you, and
Sorry?
sooner than later you will have all these networks. Yeah.
Yes.
So Nandesh, can we have our session get going?
Yes.
Hello.
Yes, sir.
So Nandesh, can we have our session get going, and can I find out about Mr. Usmani?
So yes, let's see. Let's ask him. Hello, Tawfiq. Mr. Tawfiq, can you hear us?
Yes.
Hello.
Yes.
Hello. I think sir he's not responding. Tawfiq, we want to speak to Tawfiq Ahmed
Mr.
Osmani.
Mr. Usmani.
I think he is
Is
not
Mr.
responding.
Usmani around? Yeah, he's not responding. So maybe what we can do, our very eminent, this PhD scholar from Jammu, we can have separately we can discuss these issues, and all these research related issues we can resolve, we can
Right.
find out, and maybe
Right.
we can have his ID, or you can share my mail ID with him. So subsequently,
Okay.
we can resolve all these issues. These are not big issues basically, but you see,
Right.
we just got to find out means and ways through which we could tackle these issues. Especially connectivity is an
Right.
issue, because unless he has access to research papers and these proper
Right.
communications, you won't be able. And I don't know how is he accessing all these data sets. That's a huge worry,
Basically,
especially
Right.
for Alzheimer-like disease.
I did
Right.
in the month of March, April. I was in the university. I just came 1 month back here. 14th of March, I came back home.
Okay,
I was in the university. I did my first presentation, luckily, on the 14th of March. And then I came back
okay,
here. Yes.
okay. So enjoy
So
yourself
you're
and
lucky, you're
enjoy,
very lucky.
keep attending these programs.
Yes, yes,
So
yes.
maybe we can have something in consequence. You can also write to us, and you can also give your feedback as to how helpful it was. You can also write to your government out there in JNK, especially at the moment this is centrally administered at the moment. So you can just write to them. You can always state that it was handy, because we should also get some kind of a response from the government. So it is good, and any digital communication that always remains. So yesterday also I had requested all participants that you please do write, and because that will help us, in at least starting a few other programs, launching other programs as well. So that will help us. Nandesh, you can go ahead with this session, and the concluding part, then we can have all these discussions.
Okay, sir. Okay. Okay, so everybody is back. So we can start. Please type out yes if you are there, if you can hear me. Okay, great. Great. So let me just do one thing. Yeah. Okay, great. So now that we have understood, or we have talked about a lot about the advantages that we have using neural network, how can we process information through the neural network? Are you able to see my screen? Yes, we can talk about all these things, maybe after the session. Let's come back to the topic that we have at hand. Okay, so what I was saying is that we have talked about a lot about the advantages that we have using a neural network. Now let's see, if these are the advantages, there has to be some disadvantage, or if there is advantage. So there are few advantages that we have using the neural network. So let's see why there are advantages to the neural network. First of all, let's try to understand that. As I said in the previous slide, that neural network for some people is like a black box. We don't exactly know what sort of feature selection is going on, what sort of feature extraction is going on, how it is taking the dimension of those particular features, different sort of manipulation which is happening on that particular neural network. We don't know that, how it is making, if it come to conclusion, what is the reason, because we as humans, we always believe in reasoning. We want to know if something happens, then why this thing happens, right? We want to know that, reasoning, we always interested in reasoning. But in case of neural network, we don't have that advantage to know about the reasoning behind the neural network, that how they are processing information through different hidden layers and input layers and output layers, and what are the key factors based upon which they are making a particular decision. So let's try to look at that. So where we cannot, so now somebody will say that, before addressing to this question, somebody will say that where can we, before jumping to the neural network, I should have talked about this, that somebody would say that where can we have talked about a lot of things about neural network, how do they work and all stuff. Now somebody would say, where can we use the neural network? So I would say, you can use the neural network everywhere, wherever you want, in all the fields. But do you want to really use that neural network for solving that particular question, that particular problem? That is a question that you have to ask yourself about after going through these disadvantages that we are going to talk about. So where we cannot use the neural network, let's see. So in the system, in the law, where we are making some decision, if we are maybe giving some punishment to a culprit based upon some analysis, maybe we have deployed a deep learning model, we have fed a lot of cases to our deep learning model, and our deep learning model decides something, that this person should get this number of years of jail time, or maybe whatever it assigns to that particular person, whatever suffering he has to go through. But we want to know the reasoning behind it. So the neural network will not be able to tell us about, due to, according to this section of the Indian Penal Code, this person did it, and we won't be able to see the judgment. So this is one of the example where we will not be able to use the neural network. And also there are other difficulties that we have when we talk about neural networks. So let's see what are those difficulties. You know, you are saying, sir, you have talked about a lot of good things about neural network, but now why you are talking about the bad things? But I have to, I have to do that. So the first difficulty that we have when we thought of working with neural network is computation, because training a neural network, it's going to require a huge amount of computation. You will have to require lots and lots of GPUs. You might be thinking that, yes, I have a GPU in my system, maybe of 8 gigabytes or maybe 16 gigabytes. I can train a machine learning model. So I have to say you cannot. And the more, that is the one of the major problem that we face when we talk about neural network, when we talk about training a neural network. Because training a neural network, it is going to take lots and lots of hours. Sometimes it takes 10 hours, 15 hours. The normal, when we talk about the simplest neural network, it has a very less amount of data. It might take maybe probably 7 to 8 hours, maybe 10 hours, the simplest neural network that we can talk about. And the second problem that we have, we need data. We need a large amount of data, huge amount of data. The large, by large what I mean, maybe millions and millions of numbers or data points, or the data, whatever sort of data we are trying to deal with. This is also very subjective. When somebody asks me that how much amount of data I should have train a particular machine learning model, it's subjective. But let's say for a broader perspective, I would say it's very large. Usually if you want to get your model to make good predictions, you need to show your model lots and lots of examples, because it is only going to learn from the mistake, and by seeing all the previous examples. So more the examples you will show, the more the accuracy the model you can have. So Viduti is saying, how do we use the neural network? Like, so we'll talk about this, Vidushi, we'll talk about this. Just wait for it. So as I said, that about the day computation is a problem. Then we talked about data is a problem that we have. Then we talked about, that we don't exactly know why Mark made a decision. If he made a decision that it is a cat based on what thing that he saw, he made his decision. I just gave you just a simple analogy so that you can understand it, but what exactly happened behind it, we don't really know. We don't really know how he's making that particular decision. What are the feature this layer got? What are the feature this layer got? So we don't know. For us, it's just a black box. Now let's talk about the number of input layer, the number of inputs or number of the total neurons that it might require. Before moving to the data points, let's understand how many number of inputs or how many number of connection are going to be there. So let's look at this. So this is going to be the 6 input layer, 6 hidden layer, then 6, and then these are then come be combination of these, and so on and so forth. So it comes out to be the number that we have is, I guess, how much is it? It's 90. So we need 90 connection. So what is this 90 means? 90 are the number of features, you can say. When we talk about data point, the data that we have seen, the first algorithm that we applied on that has only one feature and one output target that we talked about. So we applied our machine learning model on that, and you have seen how much hard work we did to code that stuff. But here we are having approximately 90 parameters. And if you remember, previously I have shown you the number of parameters that we would require to train a linear regression. There were 3 parameters, right? Theta, yeah. If we talk about multiple linear regression, we would have this sort of parameters: theta naught, theta 1, theta 2, theta 3, and so on. The number of parameters, the number of features that we have based upon that. The simplest linear regression that we talked about, in that case, we had 2 parameters that we were trying to reduce. If I go back and if I try to show you that, give me a second. No, it's not. Yes. So these were the parameters that we were trying to find. These were the parameters for the linear regression model. And you have seen, how much hard work we did to calculate all those things. But here we are talking about the number of parameters as 90. So you can just imagine how much, how much amount of computation it is going to require to calculate or to work on 90 parameters. You can just think of, this will answer to your question, why do we need large amount of computation power? Now let's try to understand this, that let's imagine that your granny makes a very good cake. You love the cake that your granny makes. So you try to depict, you want to eat the same cake which your granny used to make. So you want to depict the recipe which she used to do. So you try this at the first place and you find that out that no, this is not what my granny, what I ate, what granny made. Now what you have to do, if you want to make the cake that the granny used to make, you might have to give lots of tries. You have to tweak lots of things. You might have to add this amount of sugar. Maybe you have to keep the oven at this particular temperature. I don't know much about cooking, but let's say there are lots of variables that we have to take in account. And also we have to try this thing multiple times. So this is what we have to do, the same thing here. We have 90 parameters and we are going to calculate them multiple times, because first time we calculate them, then they will make a mistake, we go back, we update them, and so on and so forth. So this process continues. So you can imagine, the amount of computation it is going to require, and the time as well. We can deal with the time, but the computation is going to be a problem. So if somebody have idea about graphic cards, if you can go on Amazon, if you can search for the graphic cards, so you might be thinking, yes, I have a graphic cards, let's look for the price of a graphic card. Let's say we want to use the graphic card we thought of, and we say that we have a graphic card. It's NVIDIA GX something, GeForce 208 GTX. What is that model? GTX 200 something, I guess. 280. It's something like that. So let's see what is the price for it. Because it's not available on the Amazon. Let's try to look it. Oh, it's not there. It's not there. So you can see it's close to 600 and close to $700. That's a 7 multiplied by 7, that's around 50 to 60,000 in Indian rupees, 60 to 65,000. Now you might think that if I have this, I'll be able to do my I will able to train my machine learning model. But I would say that is not true. If you have this graphic card, that's good, but this graphic card is good for playing games and maybe watching 4K videos, recording 4K videos, rendering videos, and all that. But when we talk about training a machine learning model which has a very large amount of data, it's not going to work. Then what kind of graphic card do we need? What researcher used basically when they train their machine learning model? What Google used to train their machine learning model? So they use this NVIDIA Tesla K80. Let's see, NVIDIA GeForce Tesla. The first thing I get, Tesla GeForce. Yeah, Tesla P80, something like that. That's what they use. Let's check the price for this one. So you can see it's close to 5,000, and you can imagine, in Indian rupees, how much it would cost. And this is the graphic card that we have when we talk about the data centers. This is the graphic card that Google uses in their data center, Facebook uses in their data center. And this might as well fail sometime. To be very honest, this might fails. And the reason you might be thinking that why this is so costly, let's try to look at this. I have this example here. Where is that? Yeah, let's look at this way, that why this graphic card is so costly. The reason is because you might have heard of Bitcoin. So people are using NVIDIA K80 to mine Bitcoin. And as you can see, this is the share price of NVIDIA, and it is tracking exactly the share price of Bitcoin. So you can imagine there must be some correlation. Being a data scientist, that there is actually a correlation that we can definitely see. So that is why it is so costly. And even if you have one, it is not going to work basically. So you might need a lot of graphic cards like that. So that means that we don't, we never gonna train a deep learning model. It is just a fascinating thing that we have heard of, and we never gonna work on it. I'll definitely answer to that question, but let's just wait for now. And we talked about the second problem, that is data points. That how much amount of data do I need when you say. So let's look at this way, that let's say that I have, in this case, I have 90 parameters to train my model on. For now, let's just say I have 90 parameters. Now, if I want to train my model, how much amount of data do I need? There is a rule that we have for it, and this rule is called rule of 10. What does it mean, rule of 10? This means that the number of parameters you have, multiply by 10, you will have the data point that you would require. So that means if you have 90 parameters, you can multiply that with 10, and you might need 900 data points. So that is also huge when we talk about training a machine learning model. That's very huge. Let's see how many parameters do we need when we talk about training an image data set. Let's say we have this image, and we have this image is 25 cross 28. This image has pixel 25 into 28. So let's see how many input layers do we going to need. So can somebody, if somebody is good at maths, can somebody tell me 25 multiplied by 8, how much is it? 25 multiplied by 8, what is the value comes out to be? I guess I have to answer that. It comes out to be 700 basically. So what I mean by that? What I mean by that is my input layer is going to have 700 neurons. 700 neurons, and that is going to multiply with the hidden layers and all the other layers that I might have. So now I would have a parameter close to 4200. Now you can imagine the amount of data points that I require if I want my model to predict any image data set that I have. Okay, let me repeat that again. So this is the image that I have. Let's say that this is the image that I have, and I want to train. Yes, I'm repeating. So I want to train my deep learning model to predict this particular image. I have some image data, let's say that to be a cat or dog data. So in that cat or dog data, the pixel size for that data set is 25 cross 28. Let's imagine that for now. Okay, so the input layer, what is the number of inputs that I'm going to have? In this case, the example that I've shown you, in this case, the input layer, we thought, or we considered, just for the example, that we have 6 input layers, and so on the other hidden layers, and then the output layers. So let's see in this case how many input layers do we need. So 25 cross 28 is 700. So we will have 700 input layers. So you can just think of it, 700 input layers, then the hidden layer 1, then the hidden layer 2, then the hidden layer 3, then the output. So the total neurons that my machine, my deep learning model will have is close to 4200. Now, as I said, the data point, the rule 10, the rule of 10. So how much data do I need for it? What is the number of images that I need for it? The labeled data. Can somebody tell me? $42,000. What about the others? Why I'm not able to see responses today? Okay, so that was another problem. That means we require a huge amount of data. That is 42,000 images we need. 42? Yeah, 42,000, that's right. 42,000 images we need if we want to classify a model which has close to 4,200 parameters. And then you can think of the time that it is going to require to run that particular deep learning model, and also the computation power that it is going to require to run that particular model. That is again a problem. To collect that amount of data, you have to do lots of web scraping. Maybe you have to find different resources for that. That is also a problem. Yes, it is very difficult to get this amount of data. So now let's imagine that let's imagine that we found the data. Then and only then, if we will have a training data set which is of close to 42,000, then we feed the data into a model, and then only then it is going to give me some output. Now this is the problem. Now you might understand why there is a problem. And now if I talk about how long it is going to take to train this particular machine learning model, it might take hours. It might take 10 hours depending on the GPUs, that the kind of GPU that you have, because you can imagine the model has to now learn 4,200 parameters, and it has to train one data point that it has, one image. It has to process that image through the 4,200 data points, and it has 42,000 data points. So you can imagine the amount of computation that it requires to train 4,200 parameters on 42,000 image data. You can just imagine that. And your computer or laptop that you have, it might not work. You might be thinking that my laptop is really good and it will work. The computer that I have, it's really good, it will work. It will not work for this amount of data if you want good accuracy of your model. And it might happen that first time you run your model, you get particular amount of accuracy, maybe you get 60 to 65% accuracy, then you might need to go back, you might need to rerun your model again. So that means the hero here, or one thing, GPUs, basically that's a plural that we need, not a single one. We need multiple GPUs to train our model, and we talked about this. So I've shown you the price of GPUs, I guess. So what you can do, instead of buying a GPU, what you can do, you can use the different cloud services that we have, Amazon Web Services, Azure that we have, Floyd Hub that we have. So you can use them. So they provide you some credits. Amazon provides some credits and to run. So let's say if you want to run a model for 10 hours, so maybe it costs you around 150 or $100, somewhere around that. So how long it is going to take, it is going to be your call, whether you want to use that Amazon Web Services or not. So trust me on this, the Amazon Web Service or any web service that you say, the amount of credit that you are going to get, they're going to run out very quickly. So that means that whatever we have learned, we won't be able to apply it. We won't be able to do any manipulation on the data. We won't be able to solve, problem that we have, or that we can solve with the help of deep learning, because it's very amazing, to use deep learning. It's very, intuitive to know about, to train your model on that and to get the output. And it's very interesting to know also what exactly it is doing behind the scene, what is exactly happening in the black box. So until you train a model, you won't know about that, right? It won't create the creativity in yourself that you want to know more about that. So that means we can't do it. Well, we can. There is always a solution for when we have a problem. There is always a solution for that. So I do have a solution for it. We can use Collab. Have somebody heard of Collab? Google Collab, the service that Google has provided. This is an open source project that Google have. So we can use Collab. So in Collab, we have the GPU setting. Are you guys familiar with the GPU setting that we have in Collab? No. So in Collab, you can use GPUs also. Right now, your Collab that you might open, it might be connected to a particular CPU on a cloud or somewhere, right? But what we can do, we can connect our GPU. This notebook that we have, it's just like a Jupyter notebook. It's just like the same. What we can do is we can connect the same notebook to the GPUs. Let's see. We have to. So everybody open this Collab on your PCs or laptops, whatever you're using. Can you open it up? Did you open Collab? Okay, great. So go to runtime. Everybody go to the setting runtime. Once you go to that setting, let me know, please. Ma'am, go to your drive. How can you open it up? Okay, let me show you. You can go on Google, just type Collab notebook. The first link will come of Google Collab. It's run. It does run on your Google Drive. So this is might you get this might link. I'll share it on the chat window. Yeah. What do you have to do? You just have to go up here, click on new notebook. Please do that. New notebook, create a new notebook. So once you are in your new notebook, you can give the name whatever you like. But the thing that I want to point you, just click on the runtime. Click on the runtime, please. Can somebody tell me, are you following the commands or not? Are you on your runtime? Okay, great. So what do you need to do? But it's slow. That is the problem with your internet, ma'am. That is not with Collab. So what you have to do, you just have to go to the runtime and then look for the option change runtime type. Find this option and type yes once you find it. Did you see this option change runtime type? Great. Click on this option. Click on this option. This is the window that you might see, and it says runtime type Python 3. That's what we need. It says hardware accelerator. We need to click on it, and it might show you this option, GPU and TPUs. You can also use TPUs. You might need different settings for that. but you can obviously use GPUs. Click on the GPU, then click on save. Now it might take some time and it will show you connecting. Now we have connected our notebook to the GPU. That means we can apply deep learning model on the data that we want to train. But training a deep learning model is very difficult, as I have talked about. It's very difficult. It's going to take a lot of time and a lot of resources, right? So what is there a way out to that? Is there any other way that we can solve this problem? Do we have some solution? Do we have some spell for that? So yes, there are some spells that we have for it. There is a zoo background that we have in which there are already a trained machine learning model that deep learning model that somebody have already trained on their GPUs, on their TPUs, maybe for 10 hours, maybe for 20 hours. Some algorithm might take hours in hundreds maybe. So they have open source those models. So you can go to this website Model Zoo and you will find different type of trained model on this website, Model Zoo. You can search for this website. If somebody is interested in learning more about models, you can go to this website, Model Zoo. You can type on Google and it will give you the pre-trained model. You can see the kind of model that you have. And they are compatible with the Keras, and some of them are compatible with OpenCV, some of them are with PyTorch, and these are again different libraries, TensorFlow, so you can see how many models you have, that you want to use. They are already pre-trained. You just have to go and just start working on them, right? Great. So we have model also, and we have another API which is developed by Google, which is also a library which has some reusable modules, machine learning modules and deep learning modules that we can use for for training our data set that we have, if you want to do some sort of manipulation or predictions and all that stuff. So what you can do, you can also go to the website of TensorFlow. Type in Google TensorFlow. So TensorFlow is again an open source project that Google did. They have whatever the training they did with their models, they just open source them, so that for the people who want to use these different types of model. So you can go on this website. Once you scroll down, you will see they have a different data set. They have data set for beginners as well. Your first neural network, if somebody want to train their first neural network, they can go and try out this neural network, which is this one that we have. Scroll it down and here we have, they are talking about the let me see, they are talking about the data set of MNIST data set. This is a data set, MNIST fashion data set basically. Now let's see how many images this data set have. So this data set has close to 70,000 grayscale images. So grayscale, everybody familiar with grayscale, right? Yeah, one can also use TensorFlow for, yes ma'am, yes. Google, this is, both of these platforms are developed by Google. TensorFlow and this Google Collab, both of them are developed by Google. So you can definitely use them. That's not a problem. So all of you are aware of grayscale. What is grayscale, or do I need to talk about this? Everybody is? What about the others? Viduti, do you know about grayscale? Preeti, do you know about grayscale images? No. Okay. Preeti doesn't know. Okay, so basically grayscale mean the images of black and white only. It has only two scale, black and white color. That's all. We are basically trying to reduce the number of pixels that we can have in the image. Because if we will have, because as I said before, we have close to 259 to, yeah, 256, yeah, something like 0 to 255 pixels that we have in an image. I mean that this much different colors that we have. So we are trying to reduce it to, you know, to only 0 and 1s, that we could have 0 and 1s only, those values. So this data set, basically what does this data set have? This data set has 70,000 images. So somebody was saying that 46,000 is a huge number, it's very difficult to collect, and I said yes it is, but that's what you need if you want to train a deep learning model. And this data set has 10 categories, but 10 categories, and for those 10 categories, what they have done, they have collected the data set close to 70,000. And these are images, they are of resolution, they are of images of different articles of clothing, and they are close to 28 by 28 pixels. And you can see they have different articles for that. And these are the labels that we have. We have t-shirt, top, or trouser one. These are label, we are giving labeling to them. If it is t-shirt, it's 0. If it is trouser, that means our, now the slides that I've shown you, in that case we had only one output node or one output neurons. But this network which we are looking at, this data set, for that data set, the network is going to be a little complex, because the output, in the output layer we will have 10 layers, 10 output layers. Are you guys able to follow me? Because we have 10 categories. Are you guys able to follow me? Ten categorical output we have. I mean, at this particular point, this is going to give us 10 probabilistic. Maybe, this is going to say this is t-shirt, this the other, then there will be other point we have which is going to say this is trouser. 10 the model is going to predict 10 different variables. Just try to understand that. Hang on. And then based upon the probability, whichever of these variable that we have a higher probability, we are going to say that this item or this image that you are feeding into the system, it's this image. It's belong to this class 1, maybe the class of a trouser, this belongs to the class of a pullover, this dress, and so on and so forth. So they have defined the classes in this way. Then this is the shape of our data, that the trained data, what they did, basically they have 60,000 images for the training, and they kept 10,000 images for the testing purposes. They are going to train their model, they are going to show only 60,000 images to the model, to the deep learning model. Rest of the 10,000 images, they're gonna keep them for the testing purposes, so that they can check how accurate their model is, basically. So with length, we are just checking the number of data points that we have. Then this is how the train labels are stored. We have an array which is storing the labels 0, 9, 1, 5, 0, 9 for them. These are the values that we have for them. Now this is again the test images data set that we have, on which we are going to perform the testing. This has close to 10,000 images, and if we go and check the length, it's 10,000. Now first of all, before feeding the data into the system, the most important step, if I talk about machine learning or deep learning, is the pre-processing of the data. There has to be some sort of pre-processing. So pre-processing before the data, if you inspect the first image in the training set, you will see the pixel value fall in range 0 to 255, right? So we can see this is the image that we have. This is the first, any image that we are trying to plot. This is maybe the image that I have in the training image data set. This is at the 0th index. So this is what it looks like. So this is how the pixels values are assigned. You can see in the graph basically. It has close to 250 or 255 values. You can see that. So scale these values. What we have to do, we are going to scale these values. We are going to reduce the scale from 0 to 255. We're gonna make it from 0 to 1 so that we can do better predictions. So scale these value in the range of 0 before feeding them to the neural network model. To do so, divide the value by. So what we're gonna do, we're gonna divide. It's a simple math always. It seems complex, but it's always simple. So what we do, we just divide the training images by 255 and the testing images by 255, because eventually they will have some value to them. Maybe 255, maybe 149, maybe some values, right? So if we divide that by 255, so we'll get the values in the range from 0 to 1. Now, then after that, after doing this, to verify that we have done the same thing, to verify that the correct format that you ready to build and train the network, what we're gonna do, we're gonna check the first 25 image of the training data set and training data class and name below. You can check these images. So this is a figure plot that we are using. We are using the for loop for I in range, the range that we have. We are going to apply a for loop for this. We are only going to check 25 images. We are going to create a subplot, 5 by 5 subplot, 5 rows and 5 columns, and we are increasing this value, the first subplot, second subplot, third subplot, then so on and so forth. And we are not giving any value, we are just giving this sign on the x takes and y takes. This is what we wanted. Grid, we are also giving false, and now we want to check the image show. How we're going to do? With the help of loop mcm. This is again a function that we have for it, and this is how you can, it is going to show me the class name, because I have created an object in which I have stored all the classes. If I go up, this is class name, so I am also going to print the class name below that. You can see yeah, class name and train labels. So this is the attribute. After reducing it is from 0 to 1, converting into grayscale, this is what it looks like. And this is t-shirt, so on and so forth. You can see we have close to 10 cross 10 images. No, how many images? Yeah, we have 5 at this side, and 1 2 3 4 5 at this side. Yeah, 25 images. Now what we're gonna do, we're gonna build a model. So building a neural network require configuring the layer of the model and compiling the model. So then again, this code is going to be a little bouncer for someone, because I haven't talked about the sequential layer, how the sequential work, how the flattening work, how the dense work, how the activation function. I've talked about the activation function. So I'll try to do it for now. Let's see the best I can explain you. Let me try to do that. So I am going to use one of the blog, and I'll try my level best to explain you this how the convolution, because convolution is an important part. This sequential function is going to do, put all the layers in, because see what is this functions are doing. This is doing different operation, like we have different layers, right? These are different layers we have. So these different layers are going to perform different operations. So what those operations are going to be: first, it's going to flatten the data, then it is going to do the dense going to do the densing of the data, then it's going to do the dense of the data. So let's try to, there is another function which is sequential function that we have, and yeah, then we're going to use compiler and all, and you can see. Let me try to talk a little about what is a sequential function means basically, or what is convolution mean basically. Let's try to understand that. So now that we have our data, let's say this is my data point, or this is my image that I want to identify. This is going to be like an array or matrix, whatever you want to call it. What I will do, I will create a kernel. Kernel is going to be something, because I'm not going to look at this data at one time. What I'm going to do, I'm going to divide this data into different parts with the help of this kernel. what do I mean by that? Let me try to make you realize that. So I have this matrix which is a 3 cross 3 matrix. What I'm going to do, I am going to take this matrix and put it at this point, this point, this point, this point, this. That means 3 cross 3 I am going to cover, and then I'm going to do some manipulation, mathematical manipulation, multiply the values, add all those values together, and whatever the output I will have, I will store that into another matrix, this matrix. Did you follow what I try to make you understand? Did you understand what I'm trying to tell you? Please type yes or no. So basically what we are doing, basically we are trying to look into smaller details, basically, if somebody is not getting it. But sir, but yes, you have to, sir, because we got only one day to cover it, so that's why I'm trying my level best that I can. So basically, what does a convolution do? Let's say I have this image of Taj Mahal, right? So if I want to look at this image, what I can do, if either I can look at this image at one time, or what I can do, I can divide this image into different parts. First of all, I'll put a line here, I'll put a line here. Now this image is divided into 4 parts, but it is also, let's say, it's difficult for me to understand, but because the thing is that these are eventually, they're gonna be some values, 0, 1s or something. So what I want to make it more concrete, want to make it more easy for myself. So what I'll do, now that I have created 4 parts, maybe I'll create more parts of this image. By more parts, what I mean by that, I am going to have this kernel or this shred, you can this kernel or this matrix that I'm going to put at this particular point, and I am going to see that out. I'm going to look at that output. I'm going to store that output somewhere else. This, all the information which is stored at this point, I have put this information at a single point. That means I have reduced the information now. I've reduced the information. This large piece of information I have reduced into this information, into one number, because it will have some number here, some number here, some number here, it will have 9 numbers. So what I'm going to do, I'm going to multiply that number with some value, and then I'm going to add all those numbers and I'm going to put them in the output. Then what I will do, I will move this matrix by 1 column, right? Because let's see, I don't have a drawing here, so I could show you guys. Yeah, let's see. Now let's say that my drawing is very bad, so pardon me for that. Okay, so I'm gonna put this kernel at this particular point. So I will have some value 1 2 3 4 1, or let's go 0 1 0 1 0 1 1 1. What I'm gonna do, I am going to multiply each of these value with some numbers. Let's say we are gonna multiply with some numbers, and then I'm gonna add all these values. I'm gonna store that value up here at this particular point. This is going to be my first output. Then what I'm going to do, I am going to move this in this direction, one step at this direction. This is what I'm going to do. Now my second matrix that I will place, this kernel that I have, I might place it at this particular point till this particular point. Now these are the rows and columns that I have. 1 2 3 1 2 3 1 2 3. Now same thing I am going to do. I am going to multiply each and every value in this matrix, going to take a sum, and then going to store this value at another point, maybe somewhere here. Then again, I'm going to move it one step to this side, and this process continues. I'll move in this direction, then I'll move one step in the downward direction, then I'll have some value, and in the same way I'll have just hang on. Yeah, so in the same way I'll have some values at this point. So then what I'm going to do, I'm going to do the flattening. I'm going to flatten all those values. Now I have those values in the form of matrix. I'm going to flatten those values. I'm going to put them in single row, sorry, single column, maybe 1 0 1 0 1 0, right? In this form, then I'm going to apply some other operation on it, and then I'll have my output. So do you follow what I'm trying to make you understand? Do you follow that? Great. So this is what basically convolution is. Just give me a second. Okay, just give me a second. Okay, yeah. So this is what basically a convolution is basically. Now then we are going to apply the same operation onto it. Okay, just give me a second, guys. Can somebody tell me how can I remove this pencil marker that I have? I'm not able to use my mouse cursor now. Yeah, I got it. Okay, got it. Yeah. Okay, let's go back to the code again that we were trying to understand. Where is this? Yeah, it's here, right? So this was basically one of the function that we talked about, that was convolution, then the flattening. What happens sometimes, we try to tweak around with it. We do the convolution first, then we do the flattening. Sometimes what we do the flattening first, then we do the convolution, then dense basically. Then what does dense means? Let's try to look at this way. Dense basically, what we're gonna do, we're gonna add some extra value which are not going to be there, which are actually not there, but we're gonna insert those value just to see whether a model understand that, whether a model can. That means we are creating mistakes for a model, we are creating hurdles for a model, and we want a model to figure that out on its own, right? Just like maybe I ask you to solve a question, you gave me the right answer, then I said this is wrong, no, you did this wrong, then you will go back and you'll try to solve it, and you might come again, I'll say no, this is also wrong, this is wrong. I might say some wrong things, you go back and eventually you'll come up and you'll say this is the right method, do it. And these were all the errors that you were adding to my question, or whatever you can say that. So this is how these different operations are basically working. Also we have a few other things which we call padding. Padding are basically adding values to them, but let's not talk about that for now. I mean, it is going to be too much for you to grasp. So let's keep it simple. So let's say for now that we have these different functions which are happening by using Keras library, which is a code which is written for doing all these operations. I'm gonna have my model. So my model is going to make my predictions, right? Like the function that we have at the first place, yesterday that we talked about, the x squared plus 2x plus 5, that function that I'm talking about. So now I have that function. Now my function will make some mistake. You can also read this one, what it talks about. The first layer in this network, basically it's flattened, so it transformed the format of the image from 2-dimensional to 1-dimensional basically. So this is what I was talking about. If the image of this size, what we are doing basically, we are converting into a 1D. We are converting that image into 1D basically. That is what we are trying to do in the first step. Just hang on again. Yeah, so this is what the flattening function is doing basically. So think of this layer is unstacking the rows of pixel in the image and lining them up basically, one above one below the other and so on. So this layer has no parameter to learn, it only reformats the data. So basically what it does, it reformats our data. Okay, so after the pixels are flattened, the network consists of sequence of TF Keras.layer dense. So the layer, these are densely connected and fully connected neural network. So the one that we have talked about, in which all the points are connected to the output. So that's a fully connected layer. Dense. The first dense layer has, so these are talking about the nodes, the input nodes that that I've shown you in the slides, right? First it will have 128 input nodes. Then what will happen for the second dense is going to have only 10 nodes. The last, where is it? Yeah. So the last one will have the 10 nodes. That's what the dense does basically. Now we have some input. Then we have 128 hidden layer input, neurons. Then we have another hidden layer which is of 10 neurons. So this is what it is doing. The dense layer 128 nodes, and the second last layer is the logit, an array of 10. Each node contains the score indicating the current image belongs to the class 10. So it will have some value, and based upon which it what do they think? They will, based upon the 128 manipulate 128 layer, whatever the manipulation it will do, it will give them some input, right? Based upon that input, they will decide what do they think, whether this image belongs to which category. So if they will store this value, then they will pass this value to the output. Now let's see, now how do we compile the model? So to compile the model, before the model is ready for training, it needs a few more settings, and these are added during the model compile step. First of all, the first thing that we need is loss function. The loss function, this measure how accurate the model is running during the training, and you want to minimize the function to shear the model right direction, like we have talked about in the slide I have shown you. We were going to the minimal point by following the gradient descent. The same thing is going to happen up here. That's what we are trying to do. Now optimize, basically what is optimization is going to do. Let's look at this. So this is how the model update the, based on the data it sees the loss function. So based upon the data or the weights that I was talking about at the first place, the weights, it is going to update the weights based upon the loss or based upon the mistakes that it might create, right? Then we use matrix, some sort of matrix. So what does this matrix do? So matrix is used to monitor the training and testing step, and the following example use the accuracy fraction of the image that are correctly classified. So it is accuracy matrix that we have. Give me a second. Okay, sorry guys, can you hear me? Okay. So what I was saying basically, so let's say this matrix that we have, it's going to give me some accuracy, that how well my model is doing basically. Okay, let's not talk about all these things for now. Optimizer, let's say this optimizer is improving my loss function for now. Let's assume this. Now what we're gonna do after that, then we're gonna train a model. So train the model. The training of the neural network model require the following step. How does this training start? Let's look at this. The feed the training data to the model, and in this example the training data, train images and the train label array. So we are feeding just like we did fit the linear regression with the x and y values. So what we are doing, we are providing the input, which is the images, then we are providing the labels. Then what we are doing, and the model learns the associate image labels, and you can ask the model to make prediction about the test set. If an example, when we import the test images array, then we can verify that with the help of test labels. So this is what the training is happening. If I go back and if I try to show you the slide, you remember the code, right, that we wrote for applying the linear regression? We did the same thing for fit when we're doing the fit of the linear regression. You remember that? Or do I need to show you the model? Okay. Do I need to show you or not? Not this one. Can somebody tell me, do I need to show you the model or not? Yes. Okay. See, we have imported the linear regression. We have assigned it to the object, which is regression. What we are doing, regression dot fit. X is our input, Y is our output, right? So what I'm doing here, I'm also doing the same thing here. I'm fitting my model dot fit train images, train labels, and epochs. Epochs are basically the number of repetitions which I want this model to run on. So what I'm saying, I want my model to run 10 times. So you will see here. So the first time when the model ran, it gave me the loss as 0.499 and it gave me the accuracy of 82%. Then I go and I ran it multiple times. You can see the loss is decreasing and the accuracy is increasing. You can see that. Now we have a loss close to 0.23 and accuracy close to 90%. Now you can see the model train and the loss accuracy metrics displayed. So this is why we had the model, this accuracy, the metrics accuracy that we had. That's how we can identify what exactly is happening. Now, what we want to do, we want this is again, these are new terms for you. These are basically the evaluation techniques basically. Now, what I mean by that basically, now I am feeding my test images and test labels. Now, I have created a model. I have done the modeling. I want to check how well my model does. How I can do it. I need to pass in the new images or the test images that I haven't shown my model. So this is what I'm doing. I am passing model.evaluate. What does it do basically? It takes in the test images and the test labels and it shows you the test loss. What is the test loss? So basically we are getting the test loss close to 0.35 and test accuracy. So you can see this model has predicted 88% correctly. It has given me the accuracy close to 88% for the images which this model has never seen. These are the images which the model has never seen, and the loss is close to 0.348. And in case of, obviously the loss would be less in case of the testing, when we are doing the testing, because we are doing it multiple times, we have run it 10 times. But for the new data, the loss is also very good, it's not that bad. So it turns out the accuracy in the test data is a little less than the accuracy on the training data set, and there's gap between the training accuracy and the testing accuracy and represent overfitting. Overfitting happens when let's not talk about overfitting and underfitting for now at least. So this is what I wanted to show you about deep learning in the limited time that we have, so that you can at least have an idea how does a code work. So if you want, you can go and copy the same code and run it on your Jupyter notebook. This is my this is my Google Collab notebook. So this is my Google Collab. What I've done, I have loaded this data. So this data is already available in Keras library. Keras library, they already have this data set, which is MNIST data set. So I have downloaded this data set and I have given these values as train X, train Y, test X, text Y. So I divided this, then I applied all these layers. I did sequential, flattening, dense. I did dropout also. So let's leave it. Let's leave dropout for now. I use a different function, which is a softmax over here. Then I also use the atom optimizer. I try different optimizer also, and there are different loss functions as well. The sparse, categorical, cross entropy, there are different functions. So when I did the fit and the model at the same time. So see how much accuracy I am getting. I'm getting close to the accuracy, 97%. My test accuracy is also 97, and my training accuracy is 97, and my test accuracy is also 97. My training loss is close to the 0.7 and is also close to 0.7. So then what I can do, I can go and save this model by model.h file. This is a format that we use if we want to save the model. So that's all that I have to say. I mean, from my side, if you have any question, you can go ahead and you can ask. If you have any questions for me, you can go ahead and you can ask. Thank you. Thank you, ma'am. I just tried, I can just give whatever best possible from my end. No, you don't require Jupyter. Do you? It's online. It's available on the cloud, Dr. Suresh. You can use it online. It's like a Jupyter notebook. What are the various domains that one may all domain, everything that you can think of, everything. There are obviously different steps involved. Like you can use deep learning in NLP. You can use deep learning in translation. You can also use this in video recognition. Different sort of things you can do. Whatever thing that you can think of in your mind that you can do with the model, with the machine learning, you can do the same thing with deep learning. But do you want to do it? That's going to be a question that you need to answer yourself. Do you have that amount of data to solve that particular problem? And do you have that amount of time to run that particular model? If you have, I will say go ahead and do it. Image and video analysis. Yes, we can do the. You can have a look at these different models which are present already. So you can go and read about them if you are really excited about deep learning. I'd say go and read about them. See it. You can do this thing on audio. I mean, lots of things you can you can do with deep learning. See, there are lots of models that we have. Learning, we do some kind of coding for that. Encoding for that, we have to do that. Yeah. So somebody saying, okay, so we'll use Google Collab for deep learning. Yes, you can use Google Collab if you have large amount of data. You can run it at the GPU settings. The code might be little different for the GPU settings, so you need to make sure that you have the code which is related to. I had prepared this code also, but it's going to be very much for you for now if you ask me. So I think we should leave it. The basics would be good. I mean, you can always explore more. One more question to you: is there any association between deep learning and neural network also? So neural network, they are the part of deep learning basically. In deep learning, we have different type of neural networks basically. So neural network is one of the type that we have in deep learning. We have like RNN, we have LSTM, so many things are there. I mean, okay, any other question that you have related to the training? Thank you. That was my motto basically, just to give you little sneak peeks. I know it is going to take some time for you to grasp what we have gone through today, but I guess if you watch the video once or twice, I mean, once you watch the video, or if you can just go through the things that I've taught you, I mean, you're gonna understand it. What is the role of deep learning in business? See, deep learning, we talk about, when we talk about deep learning, we can use deep learning in case of when we want to identify, crime, maybe through the webcam also. There has been some, there are some countries which they are using deep learning to identify, to process their videos. You can Google up about it. They are processing videos, and if there is any unusual activity, then they will identify it. Also, you can use deep learning to, maybe for the attendance system, you could have build a model. You could train your model and train it to recognize faces, and if it says the face, then it will mark it attendance. You can train your deep learning model maybe for the CCTV footage, different sort of things that you can do. And also we have one fellows here. His name is, so what was your name? And you were in lovely professional university. He's using deep learning for disease recognition, some kind of Alzheimer's disease, I guess. He has collected the data and he's in the stage. Thank you so much. Thank you so much. Okay, please give me 1 second. I'll be just right back. Okay, just be right back. You there? So can you hear us? Just hang on. Feed forward neural network. Let's not talk about that for now. I mean, then there are a lot of things that will come into picture when we talk about feed forward and recurrent neural network. Lots of things will come in picture. Sir, Tableau is a forensic tool. How do you use Python with any tool machine? So basically the thing is that, so Tableau is a data visualization tool as per my understanding, and the limitation that we have with the tool is we cannot do much manipulation with those tools. Whatever functionality they have, we have to use that functionality as it is, right? And also it's a very good tool, I would say, but if you want to apply machine learning, you have to write your own code, you have to build your own modules and all that stuff. You have to do it. Any question anybody have? I mean, you should learn about Python first of all, I guess. And once you learn Python, then you can explore different fields, like about ML and deep learning. You can do that. You can use it for visualization. Any kind of data you have, you can use it for visualization. Python, I guess you can learn Python. Anybody would like to ask anything else? Anybody would like to give any inputs? Your feedback would be really appreciated. For MBA student, is it fine to learn Python? Yeah, it's fine for everyone. I mean, it's good to learn new things. But if somebody's from a Matplotlib lab, I would say it's we don't usually use it for nowadays. Python is an industry favorite. Most of the people, they use Python. Can MATLAB be accessed from Python? Some functionality that we have, like the plot that we have shown, that I have shown here, the loss function. MATLAB also have, I guess, this functionality. Some of the functionality, Python also have them. Yes, ma'am. Yes. So you can give about your feedback. You can write to us, and just give me a second. Okay, sir is here.
Yeah, Nandesh,
Yes, sir.
can we have a few responses from the participants? Because
Yes,
this
sir.
is
Yes.
we are at the fag end of this program, so maybe we can have a few responses, few inputs
Yes.
from them, because these inputs, and with you being the hidden layer, so it can lead to some nice trained output.
Yes, sir.
So
Yes. So yeah, you can please unmute yourself and you can give out your inputs. So everybody is typing in the chat window. I think they are feeling shy to unmute and give their feedback.
no, they got to speak up, because I'm in the midst of some other program also, so I can hear them. If at all
Okay,
कुछ अगर
please.
बोल दें तो हम लोगों के लिए अच्छा हो जाएगा, रिकॉर्डिंग में भी
Yes.
हम लोगों के पास रहेगा.
Yes. Yes.
This 5 minute
Yeah,
work
please.
was very good, excellent, awesome. I should say 100 by 100 to Nandesh. It was a very good introduction and exposure to three important things that are really required for research and analysis: Python, then deep
Very nice.
learning, and machine learning. So I think I have already asked him that yes, now Narendra Modi ji has extended it till May 3rd. So we should have more of such workshops for us now.
So who is going to pay Nandesh then?
Nandesh is there for us.
Nandesh. So all the participants kindly unmute yourselves. So 3 cheers for Nandesh. Hip hip.
Hooray!
Hip hip.
Hooray!
Hooray! Hooray!
Sir, I am
Thank you,
LM
everyone.
Pant.
Thank you.
Hello.
Yeah, please, Pansa, please.
Sir, I just want to submit that this was a very good workshop and there were hands-on as well. So as you were mentioning that we can extend this course for next this period of lockdown. So it is my humble submission that if hands-on workshop on these tools can be conducted, it will be very helpful for all the participants. The practical work.
So, Pansab, what we can do, hello,
Yes, sir.
hello. Yeah, my request would be kindly shoot an email, maybe all of you. Please just write an email, write to us. Our mail ID is available with you all, this USERC ID, or you can write on my personal ID also, durgesh.pant@gmail.com. This is my mail ID. So you can write to me or to USERC that such a workshop is to be organized. Then we can request Nandesh, we can request Yogendra Bhai, BRILLICA, and all others, so that not only we can take some time from them, but we can organize, we can schedule the whole thing, during this second lockdown period. We can do
Right.
that, of course, and on the basis of the need, or as you rightly said, the kind of with tools and hands-on. So we can do that part. Yes,
Right,
but
sir.
we
Thanks.
definitely need response. We need
So
response. Yes.
yes, we will give you this thing email request.
Yeah, we will be needing that, because it is all a sarkari thing. It has been organized by Government of Uttarakhand. This is Science and Technology Department. So you can always appreciate the Science and Technology Department and USERC's this effort, so that we can go on. Maybe we can have 2, 3, 4. Like we had 2 workshop. Again, we're going to have 2 more on different issues. It is on Vedic informatics. Soon we're going to come up with this thing. And on
Right, right, sir.
22nd again we have environment, other things, this is on life sciences. So in between we can again extension of data sciences, so we can have
Right,
especially deep learning. I am primarily interested in, and with project
right,
oriented deep learning. So the
right, right,
title of this program could be, yes, more
right.
responsive. I'll appreciate. Please go ahead.
Hello, am I audible?
Of course you are. Please go ahead.
Sir, I'm Dr. Vinita Sharma from New Delhi, and I attended this
Yes, Dr.
workshop
Shiv.
for 5 days.
Yeah.
And I would like to congratulate to the team that you have managed this workshop excellently. It is commendable. I have
Oh,
not
thank you.
attended such kind of workshop online. Face-to-face learning is
Thank you.
very common, but online learning in this manner, it's really a very good job you have done.
And madam, on
And
face-to-face teaching learning paradigm is fast phasing out. So you are the
yes,
you are the pioneer. You have already jumped into this fray, and this wagon will go on. Yes, please go on.
सर मैं आपसे ये भी कहना चाहती हूँ कि आप लोगों ने हमें ना फीडबैक फॉर्म भेजा था एंड आई हैव फिल्ड दैट फीडबैक फॉर्म in which you have you have given some options that which kind of workshops do we need to conduct from your side. So we have already given those options in that. So is that mail required again?
Maybe because that's a feedback form, and a mail is required because whenever all those financial requirement to this, all feasibility. So for that we just got to write to government, especially my own department. So this is some kind of a record through which we get to know about this kind of response we're getting, and people they want this kind of workshop further to be organized. So this gives some kind of a push to the overall administrative setup. How administrative things work in India, and
Yes, I
especially
do
in our
understand,
system.
sir. Yeah, agreed.
So that's why it is. Yes.
So thank you so much, sir, and thank you
more
so much
responsive.
to Namdesh.
Yeah. Nandesh is magnificent.
Thank you so much, sir. Thank you very much.
Acha, where is this Usmani? Could we get to know of him? Is he around? No, he is not possible.
Yes, sir. I think he left.
He left. Yes. Okay. Any other response? Anything? And before we finally conclude, and with a big thank you to our resource person and a wonderful instructor, Nandesh and Yogen. So, if we have no other response, so then permit me to thank them profusely, because not only could they manage the whole thing, in their perfect schedule, and conducted the whole thing so very proficiently. I'm very happy about it. Not only did they cover so many different topics, otherwise it's very difficult. And this is, I would not say it is cumbersome, but a few topics are really at times those becomes very little rigorous. So he could sail through, and he could take this entire, all the participants along. So that was the beauty of this lovely instructor. So a big thank you to Nandesh, to BRILLICA, and to our USERC team, Om Umesh and Rajdeep Jung. And above all, a big thank you to Yogendra BRILLICA for
Thank you so
conducting,
much, sir.
and to all our
Thanks for giving
participants.
us an opportunity, so that we can actually talk on these burning topics and provide us our insight. So I hope it was really helpful for you all.
Yes.
Yeah, and Yogen Bhai, now more responsibility on your shoulders, because as they are saying, as Dr. Sharma from Delhi, she is also saying other participants from JNK to DIT, all institutions and funds are from our Dehradun lab. So they want more programs of this type. With this lockdown period already extended, maybe you can come up with something interesting. So you can plan out accordingly, and we will see to it, because by the time we will be getting responses from them. So maybe I'll just I'll just try to plan out. I'll do something about it, so that one more program could be conducted. Right?
Definitely, sir. Yes.
Yeah. Okay. Thank you so much.
Okay. Thank you all.
So
Thank
stay
you.
safe.
Thank you all.
And
Thank you.
and God bless you. Thank you.
Okay, sir. Thank you so much.